surrounding the food products. However, there's a limitation for this one. This will be limited for application only in seasoning foods. Okay, what type of the foods are seasoning foods? Let's say salmon fillet. Let's say some chicken patty, small chicken patty. Then last one will be say some of the seafoods like surimi, or some of the other small sizes of the seafoods, because the dimension gonna be really matters. So you cannot do it on a beef or pork or lamb or those large ones. The seafood is okay. Okay, this is some of the example we mentioned using the food products. Okay, now last thing we want to mention here. This is going to be number 3. For some of the products, if they are high sugar or containing some of the small molecular size of carbohydrates, not really a large molecular, macromolecular, what are they going to be looks like? In your textbooks, there is a curve they talk about. Okay, this is a freezing point. This is we call it crystallization, and this is nucleation. Now this curve is a little bit confusing you. Actually, it's the same thing. This is the same thing. The only difference is the size. Crystallization depends on the nucleation because it's the size just below freezing point. Crystallization is dominant. Later on, if you do a supercooling, which means you cool down the temperature dramatically, it will start to do the nucleation, okay? Now, how about the food products has high sugar in foods? Then the curve will be changed. This is crystallization, nucleation. They will have melting points and they will have a TG. What is G? Glass status. So, in the high sugar products, they also want to do a supercooling. They try to do a supercooling is not to avoid the products generate crystal. They want to have them in a really transition status, which is a glass status. Because in a glass status, they will not form a solid 3D dimension formation like a crystal. So there's very little damage for the tissue of the products. And the curve looks like that. So they don't say it's nucleation in here, which is a glass formation. And they also have this curve tells you the crystallization, the maximum is right in the middle. This is the maximum speed of crystallization. Is right in the middle. However, this is tricky. You have high sugar in the food products. There is a 2 limitation for that. What are the 2 limitations? Number 1, if the food products has high sugar, at the same time is high moisture, then it is very difficult to do supercooling. Why? Instead of you go glass status, let's say we don't have a crystal, okay? We go glass status. Originally, they don't go glass status. They go some status right in the middle, called a rubbery status. You think about the words listening is very nice. It's rubbery status. Think about the rubber. It's so soft. However, in this status, they will be favor lots of the enzymatic reaction. Okay, this one will be favor enzymatic reaction. So, this is not really good if it's high sugar and high moisture. You have to avoid that. Number two, if in these products you have a high sugar, you have a sugar there, at the same time, you also have a protein. You have other macromolecular stuff there. Then, this TG is very difficult to determine. Because the determining of the TG not always is below 0 degrees Celsius. Some of them is way above, even 100 degrees Celsius. So you have to do the thermal process. When you do the thermal process, the protein or other macromolecular will happen is thermal decomposition. Therefore, it doesn't work very well. Now what they're going to do? What's the industry they're going to do? They add something called the cryo protect agents. Can you give me one example how we did it?
Preservatives, maybe? Like MSG or something like that?
Yeah, something like that. The common one we use. Glycerol. Remember how we storage bacteria? We add in a TSB with glycerol, we can frozen is minus 20, minus 40, is that right? For maybe 1 year, there will always be the glycerol. And usually we add sodium tripolyphosphates. What's the function of this one? Hold on water. Don't let them gone, because when they gone, the sorption and desorption isotherm will be changed. Is that right? So that is the one we do always in the lab. Okay, so we finished here. We almost finished this section about ice. But the last thing is in the textbook somewhere, but I think it's coming from nowhere when they describe this. What happened is, the curve looks like this. They talk about the water have a 3 curve, which is they call it TB, TC, and TA. And this is we call it a solid side. This is we call it a liquid side. And this is we call it a vapor side. And the melting temperature, solidified temperature, and the sublimitation. Okay, sublimitation temperature. What that means, this is AG. This is temperature. And usually this cut line is 5.0 millimeter per mercury column. They think when the temperature is a little bit higher, but the pressure is less than 4.58 millimeter mercury column, the food products will directly become a vapor. That's called freezing or freeze drying. The principle of the freeze drying. When they become a vapor, all the moisture they're gonna go. Is that right? So there is some of the freeze drying machine in the lab. They put it there. The principle is that when you lower down the pressure, And the temperature a little bit higher than 0 Celsius, degrees Celsius, it directly from solid become a vapor. So you don't have to worry about the moisture. It will be automatically dried, then called freeze drying. Okay? So here we basically finished talk about the section, and I'll just start from here, and then we're going to talk about the